Hello, good morning, everyone. Uh, I'd like to have everyone on this call. So, please, as you join the call, kindly drop your name and the local community that you belong to. And the reason for this is so that we can know the DSN community that is represented and the Umoja hack. Because the purpose for this event is actually to prepare our community members for the Umoja hack. Okay. DSN has been an important partner to Zindi on the Umoja hack, and that's because we are recognized as the largest Africa AI learning community. Okay? And then we also want our community members to not just to participate, but to lead the leaderboard. We always want to occupy a very good position, both at the beginners, the intermediate, and the advanced level. And that is the major reason for this training. So I want everyone who is on this call to please drop his or her name and also the local community that they belong to for proper follow-up. Okay, good. So this is the second training, and the last one was on Monday, and it was awesome. I'm sure a lot of people here who participated can testify to that. Okay, so for today's training, our facilitator will continue, and then it's going to be another awesome one. Okay, so now the recordings for the previous training and the links will be shared with everyone, especially the registered participants. And so if you are here to register, and the link will be dropped after this introduction. After I'm done introducing the facilitator, I'm going to drop the link to register so that you can be part of those that you have access to the recordings and also to the links that leads to the resources of this. Okay, and so without wasting much of our time, let me quickly give you a brief introduction to how to register. Now, to register for Umoja Hack, this is the link that you use. I'm going to share a shortened version with you at the chat, okay, so that we can actually pick that easily. And as a member of DSN, we expect you to add DSN as a suffix to your Zindi username. For example, as you can see on the screen, Teju Mola DSN. Okay, so Teju Mola DSN will be my Zindi username. And this will help us to track the progress, and it can also help us to give necessary support as it will be required. Also, we expect every DSN community to form a team. To participate. So on the leaderboard, we are supposed to be having each community represented on the leaderboard. So for example, as you can see here, DSN XU. So we expect DSN XU, we expect DSN LASU, DSN Unilearning, DSN Abuja, DSN Uni Abuja, DSN Uniport, all our campus communities to form a team, that bears the name of their communities and represent the community on. So we want our community to be top, and that is why. So yeah, you have access. You can ask questions, and this section is going to be very explanatory and it's going to be well detailed. Now, don't forget that this is a series, and we are ready to make sure that we give the necessary support. There's going to be another class on Monday, and then after that one, we'll be inviting, on the one on Monday, we'll be inviting Nasiruddin. That's popularly known as Zindi Active. He's a Syria hackathon winner on Zindi and on Kaggle. So I won't also expect you to miss that one. And after that section, we'll be having another section on Thursday. This is a panel section. Yes, a panel section where we're going to be having previous Umoja hack winners. Are going to be having on that call. Are going to be having on that call our facilitators. Are going to be having on that call the country ambassador for Zindi, who will give us detail. You can ask any question from him on Zindi and how to register. And if you are facing any challenge, he's a Zindi country ambassador for Nigeria. So without taking much of our time, you can drop your question on the chat box. I'm going to be picking it. And always also forget that you need to drop your name and the local community that you belong to, local DSA community that you belong to, so that we can collate it for proper personalized support. Okay, so I will also be dropping a link to a Telegram group where conversation can continue. Yes, conversation has started already on the Telegram group, and we want it to continue there. Even outside this training, you can always ask questions, and because we are going to be adding our facilitators to that group. Okay, so without taking much of our time, I want to welcome everyone once again to this event. It promises to be good and to be awesome and to be hands-on. Okay, so I'm sure you're ready with your laptop. You're ready. You've launched Colab, you've launched Jupyter, and then you're ready for this class. So let me, with honor, permit me to invite our facilitator. Is not new to some of us. Okay, he took the last section. Person of Israel, Ode Ajo, who is a data coach at Join Momentum UK, a data lead, global head technology, is a consultant and facilitator of Emirates Consulting Limited, Tableau Data Developer Ambassador 2022, TensorFlow Developer Certified, Zindi Africa Ambassador, and then please offer me the privilege to invite Israel as he takes the mic and continue the section. Israel, over to you.
All right, thank you so much, Teju. Thanks for that introduction. Good morning, everyone. It's an honor to also be here again this afternoon. This morning, rather. Sorry, still morning. So I think we can continue from there. Thank you. The next slide.
Yeah, good morning, sir.
Okay, just like an edge on also to that conversation. I remember Teju mentioning that a number of people who are here are people who have won at one point or the other on Zindi platform and of course other different hackathons. So it's good to also take note that I was privileged to win the first Trailblazer qualification challenge by Zindi that started in 2022. It was of course by Zindi. The project or the hackathon focused on supporting South Africa. About 495 fellow data scientists participated in that competition. Also, I was privileged to win the Data Science Africa 2021 Data Hackathon, organized by JDR, arm.com, and of course, about 524 fellow data scientists participated. At the moment, I'm also one of the top 10% of data scientists ranked on Zindi platform. So that's just to give an edge on to some of the reasons why it's an honor to be on this call. Okay, so we can move on. I did a bit of introduction to Umoja Arc at the last section, which I think is also important to say that again this morning before we go to another problem we're trying to solve this morning. The overview of the Umoja Arc, getting started with machine learning, exploring what the quantitative data science is all about, and on section of machine learning problem. But at the last class, we looked at big maths for regression problem, while today we're going to be looking at financial inclusion in Africa, which is the classification problem. Yes, please, we can move to the next slide. Right, so Umoja Arc is an annual machine learning hackathon, just like Teju mentioned. It's an event that brings together data scientists, machine learning engineers, and researchers from across Africa to solve real-world problems. And the key part is that we are using machine learning to do that. Yes, we can move to the next slide. I don't want to bore you with that conversation, but you can always go to Umoja Arc Africa.com to see more detail around it. Of course, during the Umoja Arc African participants can form teams. Teju also mentioned that starting this call. Also, you can work together to develop innovative solutions to a variety of challenges we, cut across beginner, intermediate, and advanced. So from what has been released on Zindi platform at the moment, it shows that the beginner problem is going to be something very close to what we did at the last class. It's going to be a regression problem around numeric values, while the intermediate is going to be something around classification, while the other part, which is going to be the advanced, is looking at reinforcement learning. I guess something is happening to the screen. Can somebody help out from the admin? Or is it only from my end? I can see that it's covered. Okay, thank you very much. So these are some of the things that is going to happen. And I know somebody wants to ask, what really is the difference between beginner, intermediate, and advanced? And like I mentioned at the last section, trust me, there's nothing so different from them. They are all machine learning problems, but the level of work you need to do on each of them differs. Just like we all know, if you say somebody is a beginner, you're not expecting too much from the person, but not that the competition is that very simple. But then you're not expecting too very much from that competition, or you do not might not also need too much data processing in that competition, like what you will do in advanced, where you need to do a number of advanced work on the data. And why the advanced stage is going to be something much different. So reinforcement learning, that is where you're trying to be like an agent. And of course, it's not a supervised learning, it's like an unsupervised learning. You don't have a target and all of that. So the kind of thing you want to do to that kind of competition is completely different from what you do in a beginner, intermediate, or advanced. But in all, what is most important is, and my advice for every single person on this call is, please try and participate. All right, I've been privileged to participate in competition as far back 2019. And that is why over time we can also, win prizes, get recognition, on Zindi and other platforms as it were. So the emphasis is that it's important to always participate, even if they're just very new. All right, but it's important to participate in this process. Listen to what people are saying. He mentioned about there's also going to be another section on Monday, and of course another panel section where you can ask. So I think these are the ways to get started, even if you're just starting your journey as a machine learning person. All right, so we can move to the next slide, please. Okay, so this is me trying to introduce, say maybe this is your first time of looking at things like this, machine learning. And pretty much machine learning is a subfield of artificial intelligence that involves the development of algorithms and models. So keywords to take note is that we are going to be building algorithms, which is the same thing as models, that enables computer to learn and improve from experience without being explicitly programmed. So the core of what we are saying here is that we want to try to see as much as possible how we can make the computer mimic what human will do, or help us to make some, decisions without, so much explanation or too much detail as it were. Machine learning algorithms learn from data, so that's also core. So if you're going to start your journey in building machine learning models, you must be core, you must understand how data works. That's the first key thing. So you won't just come to machine learning to start building models. I'm saying this for emphasis because I know there might be people on this call who are just starting. So your starting point is going to be understanding data. All right. You have to do a number of courses on data analysis. All right. And of course, understanding statistics also is important for you to improve your model performance over time. So before we can talk about machine learning, that means that you must have a background. You might be doing a number of other things around data. Thank you, Chris. We can move to the next slide. All right, so we have about 3 types of machine learning. So this is a picture of what the competition is going to look like for people who want to participate. The first part is the supervised learning. We have the unsupervised learning, and we have the reinforcement learning. All right, based on what we're trying to do, I'm mirroring this to what the task looks like for us, for this 3 level of the hackathon, the beginner, intermediate, and the advanced. So like I mentioned, the beginner and advanced focus on building machine learning models, supervised learning, regression, and classification, while the advanced has to do with reinforcement. So you can check out Omodia App platform. All right, you can check out Omodia App platform to see each of these competitions and see a brief around them. You might not be able to log in yet, all right, but it's most important that you can start looking and picturing the kind of problem you're trying to solve. So that has been released already, so you might want to try that. And of course, I know that also the hackathon is going to be a big thing for us in Nigeria, because that date also falls to our election and all. And that is why the place of you have a number of time it's more like a 2 days, competition. So it's something you can always do over time. And one of the things people used to ask me is, then how do I keep in track? How do I, and that's some of the things I treated at the last class. His step-to-step things that you can do. 2 days, trust me, is a long time. If you don't really know what to do, if you don't really know how to go about the data. And that's some of the things I'm going to focus again. And also I'm going to advise that you watch, the previous class to get some of these insights. All right. To supervise learning, this involves you training a model on labeled data. That is the key part, on labeled data. What we are trying to say at this point is that we know what we're trying to build. If I ask you to predict the sales of a product, you know what I'm saying. I'm saying predict the sales. At that point, the sales is more like the target, right? But at that point, I know specifically what I'm looking for. But there are kind of problems that you're not so sure, or it's not so direct that way. I say sales, so you know that sales could either be, most of the time, will be number. But I can also come back to say, can you predict if a student is going to pass an exam or not? Now, at that point, when I've given you what the business problem looks like what I've just mentioned, then you also want to look at the data if it has previous information about the student who has been promoted before now or not. That is one very key thing. So if you have that kind of data, which we always call targets in your data set, that means that kind of problem is a supervised problem. If you have previous historical data about sales, all right, that means that once you have your targets in your data set, that is a supervised learning machine work that you want to do. All right, you want to do supervised machine learning model. That is what you're trying to do. But if it is supervised learning, there are two types that you're going to work with. And from the competition also, we saw that there are two major, types supervised that has been launched. But of course, it is not public yet. We have regression and we have classification programs. We're going to explain each of these at the next, slide. Unsupervised learning, pretty much that is where you don't know your targets. There is no historical value for your targets in your data sets. And that is where you need to really open your thinking cap and be able to picture what you think the targets for this kind of problem will be based on the information in your data sets. While the reinforcement learning pretty much talks about you trying to train an agent, just like one example is your ChatGPT, all right? You know how ChatGPT works. It begins to leverage on your feedback to answer questions. So, for example, if I say on GPT and say, what is 4 plus 4? And they say 8. And I tell you, no, it's not 8, it's 6. You say, I'm sorry, it's 6. All right. Why is that happening? Because it leverages on what you're saying, really. It's not as if it's just leveraging on the kind of data that is available. And that is what we're trying to do. So the agent learns to maximize a reward signal by exploring different actions and learning from the consequences, right? It is all about what you're saying. So if you say who is the president of Nigeria and he says he fetched the data from somewhere, and you say no, it's not Buhari, it's Teju. And you're going to say, oh, I'm sorry, it's Teju. So that's some of the, the limitation to, systems like that. But the key thing is, I want you to understand each of these because the competition focuses on some of these, learning fields that I've mentioned. All right, please, we can move to the next slide. All right, so like I mentioned, in the supervised machine learning model, we have like 3 types. Some people say we have 2, but the core that we use is always regression and classification. Of course, the third part is always clustering, all right? But based on what we are doing, just focus on the 2 that is most important for this conversation. Now, regression and classification are the 2 broad classification categories of machine learning tasks that involve predicting an outcome based on the input data. So the regression involves predicting continuous numeric value. Please take note of that. So whenever you see a problem, because the first thing that shows that you understand what we are really saying in terms of the business problem or in terms of the project you're trying to work on is, do you understand our targets? Do you understand what we're trying to do? That's like the first thing to ask you. Do you know what we're trying to do? Can you picture what we're trying to do? And that is one core thing that you need to, understand. So you must know our targets. So that's the first, even if you don't know the processes, and that is one of the things this class is building up, is building from beginners down to advanced really level for everyone who is on this course. So the first thing you must know is that for every of your supervised machine learning, there will always be targets. What is the target? The target is our outcome, the result we are expecting. Can you predict if a student is going to pass an exam or not? The result for that kind of problem is going to be that we want to see the student that passed exam and the student that failed the exam. I mean, that's what we're trying to say. Or a student that did not write the exam at all. All right. Those are different, scenarios as it were. And of course, we have the regression, which involves predicting continuous numeric value, like I mentioned the other time. Why classification involves predicting a discrete class or category. All right. So it's the value you are predicting at this point, their category. And we're going to be doing classification on this call. At the previous call, we did regression. So on this call, we're going to be doing classification. All right. And that is one very core thing you must know. You must be able to distinguish between your business problem. Every project you are doing has a target, as a result. And those are some of the first things that you need to pay attention to as we work on. So take away is that we have regression, we have classification. Regression, we want to predict numeric values. Classification, we want to predict class or categories. All right. So we can move to the next slide, please. All right. So like I mentioned in the last section, we spoke about regression, and regression is basically trying to predict a model for continuous numeric value. This involves using the baseline figures. Now, of course, when you build a model fitting, then you need to evaluate it using some metrics. What does that mean? You're trying to say that we want to understand how much is this model performing, right? And there are numbers of metrics that we can use. We use a number of these guys at the last class: mean squared error, root mean squared error, R squared score. But the emphasis at this point, like I mentioned also in the last class, is that at this point, once you're talking about error, that means that is the level at which your data has not been correctly, model is not correct. So one thing you want to do at this point is you want to reduce, the value that you have at this point. You want to ensure that the error is very, very minimal. So if you have a 1,000 score as your error, say your mean score error, you want to see how do I reduce it from 1,000 to like 500 or to like 200. Of course, you might not be able to reduce all of the score, but at least to the minimum. All right, that is what that simply implies on. So I think we can move to the next slide since we'll focus on classification on this call. All right, so for classification, we also have a number of classification model, and our logistic regression basically is used to build a binary classification task. So like we all know in our mathematics, binary is zeros and ones. So at that point, because your system or your data cannot just pass in the value of, say, pass or fail, it can't just pass that. It has to convert pass or fail to binary zeros and ones. So logistic regression, which is a classification model, is going to be used to predict, all right, binary values of 0 and 1. It works by fitting a logistic function to the input features and predicting the probability of the positive class. The metrics used to evaluate the admin. Okay, just continue from my end. I guess you're going to project. Sorry about that. All right, thank you very much. So the metrics used to evaluate your performance of a logistic regression model, some of them is accuracy, the precision, the recall, the F1 score. And let me also mention this at this point, that when you are working on any project, specifically every hackathon, you have to pay attention to the evaluation on the hackathon, because your model will be built and it will be tested on the hackathon platform. So there are expected accuracy or there are expected evaluation that you're supposed to do. So if the computation is asking you for accuracy and you are using F1 score as the only thing that determines your value at that point, or that is the determinant for your submission file, you're obviously going to be getting, a different result. So you have to pay attention when competition are they expecting. All right, it's they're not to use the pay attention to that once you start, ready checking out some of these hackathon platforms, specifically Zingy. All right, so we have another one called decision tree, and we have random forest. So decision tree is a type of model that we can use for both binary and multi-class classification. Now, binary is what I've mentioned, that can 0 and 1. What happens to multi-class? So when we say we have a multi-class kind of task, that means that when your target has more than 2 classes. For example, if I say, can you predict if a student is going to pass an exam, fail an exam, or not even write the exam at all? So at that point, when you have more than 0 and 1, you have the third guy there. That means that kind of problem is a multi-class classification. I've told you, I'm saying some of these things because they are the leverage to show if you understand the hackathon. All right. These are the things you need to leverage on. These are the things you have to be clear of about first before even trying to write any code. And that is why I'm taking our time again to explain some of these things for us. This might be somebody's way of getting some of these points again. All right. So please pay attention to your hackathon and be sure of the kind of problem. Just for emphasis, is it a regression problem? Is it supervised, which of course that means it's a supervised learning problem you're trying to work on? Is it a regression one or is it a classification one? What metrics are they expecting us to work with? If it is a classification problem, is it a binary classification or is it a multi-class classification? All right. So the random forest too, the random forest is an assembling learning model that combines multiple decision trees to improve your performance and reduce overfitting. Now the metrics used to evaluate the performance of random forest is the same, as your decision tree model. So the light of your accuracy, precision, recall, F1 score, Gini index, depending on what the task is expecting from you. All right, please, can we move to the next slide? All right, so I also like to discuss most time because the way we will approach problems like this, especially competition, is completely a bit different from the way we will approach the normal I'm building my baseline model or I'm just building a model for a business use case, right? And they are pretty a bit different, trust me. That's why most times they are like a structure you should follow. The first thing is when you are trying to build a model for competitions like this, please pay attention to building your baseline model first. Don't use all of your energy. Don't use all of your technique at a go. Like I mentioned, this competition is going to be like a 2 days thing. I mean, if you have exhausted all your thoughts, if you have exhausted all you can do, before one day is over, you're already exhausted and you feel like quitting the competition. And you see that there are some guys not even submitting anything, but they will just come, the second day because they are trying to build up on the guardrail notes. So I must also say that too, because it might be tiring doing competition, all right? It might be tiring because you have a long time. You are seeing people doing submission, submitting. But most time you want to just, try out as much as possible to follow processes. And the first thing is build baseline model for. See that if I do not do anything on this data, what will my model score look like on the basics? What will my model score look like on the basics? So just have a look at your data, then create a model without any data cleaning or feature engineering. Don't do anything serious. Just watch through the data. If you have categorical data, just encode them. Just build a model. See that you have not done anything. You've not done anything too serious to your data. Just pass in your data like that to the model and seal the score. So if this can, that means because that score also will have effect, if you submit that submission file. And you can see that if you do not do anything on your data, okay, your data is going to give you, let's say, about 50% accuracy. I mean, that is huge too, without doing anything serious. All right. And that is also very important. That is also very, very important. So the next thing is, and I cannot stop saying that, is that, and that's one of the things I've been emphasizing in this film, to create your problem. So if you please take out time, don't be in an hurry to build model, right? Don't be in an hurry to build models. Understand the problem, because once you understand the problem, you will understand the best use case. You will understand the data that will be important. You will understand how to do your future selection. You will know the data that will not be important from even your domain knowledge or from research. And of course, you have to create a good validation set. How many value of my data should go into my training? How many value of my data should go into my test? All right. Another thing is going to be that a good validation is a must. Only then can you trust your local results. So you must know how to do your cross validation on your system so that your data, if it's performing on your system, like I mentioned that, at the last class, if you are doing well, the fact that your model is doing well on your system does not mean that if you take that model, online, it's going to perform much better. It doesn't happen that way. But if you are sure that you are paying attention to your cross validation, your CV, what the result is, what your score is, and you are using those techniques, the light of K-fold, and all of that. You use that on your system, and it performs where the light of you doing your hyperparameter on your system, and you are sure that the cross validation is cool, and you have been able to validate your data, able to validate the model that you have also built. Then you can be rest assured that it is going to perform much better, on your submission. Why are we saying that? Is because if we do not pay attention to your validation, if you're doing well when you make submission, please expect what we call the almighty falling on private leaderboard. Now, that takes me to explain what private leaderboard and public leaderboard is. When you are participating in any hackathon, especially data that we have seen on Zindi and Kaggle or Machine Arc, and as varieties of other platforms, right? You will see that we always have what we call the public leaderboard and what we call the private leaderboard. Now, when we start a competition, the public leaderboard is available for all of us to make our submissions. At times, in a day, you might have the privilege of submitting 5, submission 5. At times, depending on the competition, some can say 10 submission 5 per day. All right. But in all of this, it's important that you don't just waste your submissions. It's important to also say that be sure that this thing is doing well for you, especially in hackathons like this. Restrictions will be so much to the numbers of submission files that you can make. I guess it's going to be like 5 or 10 for a day. Or some will do like that, but because this is a short time, maybe about 10, in a day, or 20 in a day. So you have to be careful about just making submission and making submission. Now, once with the competitions, the public leaderboard is available. Public leaderboard is where whatever your result at that point shows up, your score level shows up, your position shows up. But at that point, we are not testing because there is an unseen data that your data is being tested with that gives an assumption of what value you are having. And of course, you will possibly have a test data. For competitions like this, we have a train data, you will have a test data, you will have a sample or a submission file, while some competitions also will give you variable description file. I'm going to explain each of these guys now. Now, the test data is data they are expecting you to train your model with. The test data is data they are expecting you to test the performance of your model with. We're going to see this one, we start our hands on. They're expecting you to test the performance of your model with. All right, that is pretty much what they are expecting you to do. While the submission file is a sample of what your submission should look like at the end of the day after you have built your model and you have tested on your test data, not the validated part, the one you use to test, the test data that was given to you on the competition. All right, why you expected once it's successful, then you can make your submission file that you will upload on the hackathon platform. Is that submission file you will upload on the hackathon platform, not your code. I need to say this especially for people who are just starting or if this is their first time. Is your submission file you are going to submit at the end of the day, not your notebook, not your just data, no, not that your Jupyter notebook file. No, it's your submission file. All right. So just to say that now, when you upload it, that submission will be tested, that model, because that's the result of your model, will be tested by some percentage of the test data on that platform, on the public. Now, when do we get private leaderboard? We get private leaderboard when the competition is over. So let's say the competition will be over tonight. Once it's tonight, it now begins to also test your final results. All right, it tests your final result, whichever one you pick, or it picks your best performance for you. All right, and then we now test that model performance on 100% of the test data on that platform. 100% of the test data on that platform. 100% of it. So that is why at times, if your cross validation, if your score that you are getting is not validated, you are not so sure that it's doing well, it will allow you to fall. Or there are people you see that when we start the competition, first position, release the board, you see them at position 10, position 15, 75. Why? Is the number of over 15 on what they built. They did not check the validation of the model that they built. All right. So please take note of your cross validation and be sure that it's working well to avoid what we call almighty falling on your private leaderboard. Okay, that being said, we also need to also learn how to use variety of models. From experience, I've seen that you don't just build one model and you think you have arrived. No, that even that one model, there are things you need to do on it, and these are some of the things I'm going to do when we start the hands-on in a moment. So if you look at this, for instance, you see that we can build variety of models, the light of gradient boosting models, your CAT boost, your light GBM, your SG boost. You can also build neural networks depending on the kind of data you're working with, and you feel that that is going to perform much better on your data. Same thing, you can also use the stacking and blending of your results. And what does that mean? Just that you are trying to combine different results. These are approaches that helps when we are doing competition. For example, at times you see that if you check a competition, people's score looks almost like the same thing. And that's the truth. Models can perform that way. But most time, our job as somebody who is in the data science competition is that you must learn out, okay, I've gotten score 1, score 2, score 3. Can I combine score 1, score 2, score 3 together and get the average of the score and submit that model? So that means that if I have three results are combined together, if my result before is 0.5 and all of us looks like we all have 0.5, if I do stacking or blending, it's possible that my 0.5 can turn to 0.51. That is one beauty about learning how to do stacking and doing blending. All right. And of course, another thing is the assembling, trying different models together. It's also an edge to win competition. So therefore, it's a tool you will always want to keep handy. All right, thank you. We can move to the next slide, please. All right. So one also very important thing that will make you stand out in your competition or in what you are doing is what we call feature engineering techniques. So what's feature engineering? That is you trying to do some science work, to your data. Features is the same thing as data. All right. Your feature is your column. All right. The data that you have. So there are things you can do. So for example, on my feature, can I do imputation? Can I undo missing value at that point? Categorical encoding, like I meant, if you have categorical features like say gender, you have promoted or not, promoted, not promoted, qualification, that kind of information that we store with the objects. So you have to do what we call encoding at that point. You have to do encoding. So you have to learn how to do encoding too. Also, another thing is you have to learn how to undo outliers. You have to learn how to do binding. You have to learn how to do scaling. You have to learn how to do log transformation. You have to know how to do feature selection, feature grouping. These are things you have to take notes. Please advise that all right. So I advise you take note of this. You might do a screenshot of these, to guide you when you are doing your own or when you're building your model for personal use or, for this competition as occasion serves. Okay, we can move to the next slide. All right, so what are the benefits of participating in data science competition like Umbugia Arc? One thing is, I'll start from the last, networking. You're going to build, a wide network of people with, different background, people from different countries, people with different specialization, all right? And these are the things you want to do because people will be posting different things at, in the forums. Please engage it, check it out. Link up with the person on LinkedIn. I mean, that's how to make friends. I remember when I had in 2019, a number of friends, from Kenya that we work on projects together. And of course, many of us will also meet again on Zindi platform. So the emphasis is, you will meet a number of people, and that is the beauty. And that's the part that you really need to. And if people can validate that you are good, they can also, introduce you to other projects, work with you on different projects, invite you for, event and all of that. Another part is that you're going to be able to compete with, several people across town. This is we call this an inter-university. So almost all the universities, in Africa is participating in this competition. And that gives you a leverage to meet people, from several parts of Africa. And of course, even some people, in other parts, or continent also joins, at times. And of course, the big part is that you are learning. You are learning. You have this error, you post about it, somebody's there to say, oh, I use how to go about it, this is what you should do. I mean, that's a very big leverage for you. And the last part, which is most important, and that is one of the things that we're trying to do, is that we are getting rewarded, all right, and winning amazing prize. I mean, this is dollar, guys. So please make your shot for this. We try to make, good, dollars from this platform, and that makes a lot of sense, for all of us, reward for, some of this work, late nights, building models, is that we get prizes, at the end of the day. All right, so we can move to the next slide, please. All right, so we just move straight to, the hands-on section, which is going to be that we want to build a financial inclusion in Africa. So this is what the task looks like, and we're going to see what we can do in that regard. So I guess that the source code that you can also follow through will be posted on the chat. But I'd like to take questions at this point. If there are questions, anything you want me to clarify before we move to the other section. So that's the link to the source code that I'm going to be working with. Yeah, you can just follow through to. So I want to take question at this point. Any question from anyone? Questions, please. Let me check the chat.
You can raise up your hand if you want to ask a question, then unmute yourself to ask your question directly, or drop your question to the chat room.
Okay, can we have the source code there? Yes, please. Let me copy it again and share on the chat. All right, guys, I just got that. Okay, is this competition for just an individual or team can join in the competition? I guess I'm saying that it depends on you, just like Teddy also mentioned when we started, that you can decide, to compete as a person, but because you belong to, DSM community like us too. So once you register, once the account starts, you're expected to put like underscore DSM, to your name. And of course, because we also have cities, and that is where, many of us after leaving the university, we belong to, all right? So we advise at that point to try to put the name of our community at our back. Say, for example, for me, I'm a member of DSM, Ibadan. So I'll just put that there at the end of the day.
Hello.
Okay.
Yeah. Okay, I'm Lawal. Yeah, I just want to ask about, can you hear me?
Yes,
Hello?
you are audible.
Okay. So you mentioned something about K-Food while you were talking about using models, using different models. So I don't know, because I know that K-Food, what K-Food does, that K-Food split your data set into different let me say folds. Okay, then checks, then run a model through it, then checks the metrics, the score. So I want to know, can you please just explain on that, maybe how we can really use it to, get more score in this project? Like, just kind of explain more on that K-Food,
Right.
how to use
Okay,
it, and
I get
also how
about
to.
generally cross-validation.
Yes.
Okay, so the way cross-validation works, and I think somebody also is asking that in the group, is that it
Yeah.
helps you to be able, just like the word says, it cross-validates what your local system score is to what goes out at the end of the day. So, for example, I also experienced that even when trying to build, the model for this section, my model was looking nice on my system, all right? Like what I was calling was looking pretty good for the metric I was using. So I tried submitting that. It was just way, crazy than what I was thinking. Like, what is this one giving me? So what cross-validation helps you to do, it helps you to manage your score from your local system, all right, to what you get when you move that same model in a submission pattern in a competition. All right. So cross-validation is more like what your score is. So for example, if your score at the end of the day on your system is let's say 98% accuracy. All right. With retain, what we are saying is, will this be retained if I make this submission? Of course, the picture now is that you're doing an hackathon. Will that same score be retained if I make that submission? So, and there are a number of things that, that helps that to work greatly. One of them is how you are handling your cross-validation on your system, right? And one of the things you have mentioned, K4 is one of them, one of the approach. So, because data also is a way. So the way it splits your data, the way it helps you to manage your data also is something that is a plus, that it helps you, to retain that on your system. That's one. Two, the kind of hyperparameter tuning that you do, the light of your, grid search, it helps you to know the best parameter. I know somebody also is asking something around model. It helps you to know the best parameter that you can use, and that whatever the score is on my local system. When I'm saying local system, it does not necessarily have to even be your system. It might be on the cloud platform, like your Kaggle Kernel or your, Google Colab, or on your cloud platform. One advice that you also, read about some of the techniques that are available for cross-validation. Don't know if that answered that question. Somebody said, can you speak more on different models for training your data? Yes, as far as, you can experiment as much models that you can, and which we are going to see some of them in the section we are going into. But the core of this is that your model is determinant on how much your result is really. So the more model you try is the possibility of you getting a better performance. All right. So if I just try one model, my performance or the kind of feedback that I get is basically based on that one model. But if I try 1, 2, 3 models, all right, if I try 1, 2, 3 models, my model performs much better in terms of I can cross check, I can check the performance of each of these models, and I can now conclude that so model performs much better on my data. All right. And that's what we're pretty much trying to say. And one way to also do that is that you must also learn how to tune the parameters that you pass into models. This also helps in your model performance, especially for competitions like this. And trust me, for the guys who have been competing over time, there is a way they are able to leverage on some of these, best, tuning parameters, the best parameters for models. And there is a way they master it, and it really works for them. But in all of this, we are just trying to start. The first job is to do your grid search, pass in, list of different parameters, and let it, help you to evaluate that to get the best parameters, all right, at the end of the day. So that is my advice on how you can, use different models. Okay, Nathaniel said, okay, thanks, just to be clear, all right. Okay, I think, okay, Teji also explained that. Do we have to be a university student to participate? Well, it's a university thing, really. But of course, if you are a fresh graduate, I just advise that. The only thing they just want to see is that you have something to show. I think in the form, there is a place you're supposed to, just put in something that shows that you're a student, or you are once a student at least. If you have not been, a graduate for so long, like just a fresh graduate, why not? You should still have something that you can upload at that point that shows you as a student. It's nothing too serious, really. Trust me. And of course, you can also participate as a community. That is where the same thing plays out. The form is just something simple. You're not expecting too many things when you fill the form. All right, I think that's any other question, please, before we move to the next section. Okay, I guess you will do that. So please, where is the link to
Yes, sir.
register? All right, I can hear you, please.
Okay. I want to ask that this slide, will it be made available after the class so that one can read it more?
Yes, I think that the members mentioned that. The team already mentioned that will be shared. Just make sure you register for this webinar. So I think they mentioned that already, that they're going to share that.
Thank you, sir.
Okay, thank you, Mr. David. Mr. David said you can join any campus community. You are not a student to participate. Yeah. So I think that's a straightforward response to that. Thank you very much. So any other question, please? I thank you guys. It's a show that you are with me. I'm so glad for these feedbacks. I appreciate. So I guess I can share my screen at this point. Yeah, so thank you everyone for listening. So let's move to the next part. So this is the link I shared where you see some of the files we'll be working with, data sets, I mean, all of the files that we have. And I'm doing this on okay. So I'll be doing this on Google Code Lab. Just like somebody mentioned at the last class, what I did here was I decided to work with my Google Code Lab. At the last class, I worked locally on my system. So I decided to change the environment I'm using to do all of this at this time. And that goes to you too. You want to try as different platform, that you are aware of. And of course, coming to cloud platform also gives you a leverage for your runtime. And it's one thing that also helps us. A model that we run for, a longer time on your local system is pretty going to do much well, on your cloud platform, like a online platform of running your code. So if you want to change that, you can come to your runtime and come to change runtime type. Then you can change that to either GPU or TPU, or at least most times GPU is a good one for you that you can try out. So I won't be running this now, it's just going to be a walkthrough. So the problem is focused on financial inclusion in Africa. So let's just add a brief knowledge of what the problem is all about. So I will be reading that part in the slide. Financial inclusion remains one of the main obstacles to economic and human development in Africa. For example, across Kenya, Rwanda, Tanzania, and Uganda, only 9.1 million adults, or 14% of adults, have access to or use a commercial bank account. Traditionally, access to bank account has been regarded as an indicator of financial inclusion. However, the proliferation of mobile money in Africa and the growth of innovative fintech solutions, banks still play a vital role in facilitating access to financial services. Access to bank accounts enables households to save and make payments while also helping businesses build up their creditworthiness and improve their access to loan, insurance, and related services. Therefore, access to bank account is an essential contributor to long-term economic growth. The objective of this competition is to create a machine learning model to predict which individuals are most likely to have or use a bank account. So from what I've read, I want you to please let me see that in the group. What kind of problem are we trying to solve? Is it a classification problem or a regression problem? Anybody in the chat? Is this a classification problem or a regression problem? From what I just read. Oh, thank you, Prosperity. Classification, yeah, that's it. Yeah, thank you, everyone. So, I mean, like I mentioned, from when you read the problem statement, you should be able to identify what kind of problem are we trying to solve. I thank you, Obina. Yeah, classification. All right. Yeah, so that's pretty much what we're trying to do. So I think we are clear with that. So we know the core things that we want to do. So the objective of this competition is to create a machine learning model to predict which individuals are most likely to have or use a bank account. These models and solutions developed can provide an indication of the state of financial inclusion in Kenya, Rwanda, Tanzania, Uganda, while providing insights into some of the key factors of driving individuals' financial security. All right, so we can look at this run through. This is more like a starter notebook. And I have the next one where I really did a number of other things. So the data I'm using here, I decided to connect it. I'm just going to show you that process of who I want to use this approach. I'll show you one or two things. Moving on. I'm trying to connect. So after that, then I tried to mount my drive. So I uploaded data sets into my drive. So all I need to do is to click on mount. So if you click here, it asks you to authorize that you should make use of your drive. Once you do that, then it pops up this code, all right, that shows that you have successfully merged up your data. But of course, it doesn't change all your pd.read, but it's because I'm moving my data, from my system to this kind of platform, right? So when I want to run it, I decided to do, can't see your screen. Oh, guys, can you confirm if you can see my screen? Someone just said I can't see your screen. I see it. Okay, good. Thank you. I can see it. Oh, thank you, guys. All right, so I guess that I want to try and look at your network again. With that, thank you, guys. All right, thank you, everyone. So that's what I did at this point. So I just decided to, let me make my screen a bit bigger too. All right. So I decided to import the necessary library that I need. So here I loaded my file into Pandas data frame, the train, the test, and the sample submission. So here I try to also observe the shape of my data sets, the train, and like we know, can this data importing technique work for someone using Jupyter? No, you don't need to use that. If you are using your Jupyter notebook, I just decided to use another approach because I used the one you mentioned. You don't need to do all of that. All you just need to do is your pd.read CSV after you have imported your working libraries. I hope Ismail got that. You don't need to go through this stress. I'm just saying if you want to use this kind of platform I just had to change the platform since, just PD exactly. That's all you need to do. Thank you, man. All right. I'm using this just to change, the approach we followed at the last class. All right. So I decided to check my train data and my test data. Just because we all know that we are trying to build a supervised learning, we will not always have our targets in our test data. That is why you see that you have 13 columns in your train and you have 12 columns in your tests. All right. The above output shows that the number of rows and columns for train data, we have 13 variables, that is features. In our train data set, we have 12 independent variables and 1 dependent. In the test, we have 12 independent variables. All right. Our target will not be in our test. So I try to check my data. I use the train.ed. So I have the following features. We have the country, the year, the unique ID, the bank account. That is our target, the local type. So I know that many of us know that most time we have our target as the likes feature. So it might change. That is why you have to understand the task. Most time we always want to say is at the end, but right now you see that it's just in between the data. So that is why you must understand the business problem, so that you can maximize what you're about to do. Location type of some of these guys, cell phone access, the household size, the age of respondent, the gender of respondent, relationship with ed, the marital status, the education level, and the job type. All right, so I checked through if there are missing values. So I noticed that there are no missing values. Okay, where did you get the data set from? So it's from Zindi. All right, it's one competition on Zindi. The data set is already in the link that I shared, and I want to check it out on that platform. All right, so the next thing I did was to know the number of countries that we have. So I can see that we have 4 countries. Oh, okay, I didn't get the targets. So if you read the task again, the task is that we should predict if a person is going to have a bank account or not. If the person is going to have a bank account or not. All right. So if that is the task, that means our target is that. So that is our target. What we want to really get is bank accounts. That's what we, of course, you can see that it looks as if it has value here, right? Yes, because it's showing us historical data. It's showing us the previous data. It's showing us what has been happening before now. You get what I'm saying now? It's showing us what we've been having before now. So now you have seen what data looks like before now. Then can you now, and that's why I told you that before you start building machine learning models, you have to understand your data analysis. So this is what the data looks like first. So can you look at the data and understand it? Then can you now use a data, which is in my test? You look at this test now, look at this for instance. I hope there is a place that I run my test. Okay, I did not run test because I did not need it at this point. If I look at my test, yeah, somebody said binary classification problem. Yes, so that is the target. But if you look at this, my test does not have the target, that is why it's having 12 columns. That means you know that the train one has 13, my test has 12. So you see that one is missing, right? So that one that is missing is the bank account. So most times the target will not be available in your test data because you want to now use this test data to now evaluate the model that you build. So at this one that in the test, it will not now have values for this yes, no, it won't have a value. It's now we as the machine learning experts that will now be able to build a model that will now generate value for back and count yes, no, that kind of value at the end of the day. All right. That's what our target is. I hope that explains what that is. Also, we check the back account and look at what we have. These are our targets. Our yes is very small, while our no is very big. So first thing you must know at this point, when you check your target like this, and you see that there is a particular class that looks very big like this than another one, you must know that it already shows that there is imbalanced class here. Because the probability that is going to predict no is very, very high. Because no has dominated the historical data. Please take note of some of this, because there are some of the things you will need to do to improve your model. They won't tell you that, but it is your job to know some of these things. And that is why we are taking this class and trying to look at some of these key things from our data. So you have to visualize your data, and that's what I'm doing here. What I'm showing you here is what we call the EDA, exploratory data analysis. I'm trying to visualize each of these columns to generate insight, from there. So what I saw here, before I even go there, let's just take it line by line. We have the countries, Kenya, Rwanda, Tanzania, Uganda. So from this data, we can see that we have more, people who fill this survey from Uganda, followed by people in Tanzania, followed by people in Kenya, and followed by people in Uganda. That is what we can see at that point. Well, at this point, we can see that a number of people who fill this survey has a cell phone. All right, that's what we have here. While the bank account, we can see the number of people who fill this survey do not have a bank account. This is for information's sake. What I'm saying now is for information's sake. But because we have an intention of building a machine learning model, this is our target. And once a particular class in your target looks way bigger than the other one, you must know that it's an imbalanced class and you must undo it. Now, why do you need to undo it? Is because if you do not undo it, there is a very high tendency that your model is going to predict a no. Because in your trading data, you have no at a very high range. All right. That is what imbalance is. Imbalanced class means that there is a particular class, all right, in your targets that is way bigger than others. So the tendency of predicting that particular class is very high. Another thing I checked was to check the location type of people who fill this form. And you can see that most of them are in the rural, all right. And of course, so and that assumption there is that possibly there are no banks, all right, bank location, for them to easily, identify. The number of people who feel these are female. These are just information. Relationship with the head, that is the husband. Many of them are head of household, all right. Some of them are spouse. Some of them are children. A little number of them are parents. Some of them we don't even know where they belong to. Others non-relatives. Others relative relationship. Others relative. Okay. We also check the marital status, and we see that a number of people who feel these are married, living together. Some also I decided to use an order so that it becomes easier to use. So we can also say that single and never married, widow, divorced and separated, because don't know does not exist with a huge value, so very small. So also we check the job type, and we can see the job type of people who fill. So most of the people who fill this survey are self-employed, followed by informally employed, farmers and fishing, followed by remittance dependent, followed by formally employed private, other income, no income, don't know or refuse to know, all right? They decide to ignore them. So like I mentioned, we check the bank account again. just to show what I emphasized at that time, which shows that we have a huge value. Okay, then guys asking some of the features that are having imbalance. So not all of the features. It is all about the targets. It's just the record, all right? That is not imbalance. That's not imbalance really. It's just the values that we have for them. But the reason why we pay attention to the one callback account is because it's our targets. All right. That's why I said imbalance class or imbalance targets. So the reason we are paying attention to that one, or the reason why I raised that one, is because that is our target. Not because others are known. Others data can be like that. And of course, even for analysis sake, this bank account is you can use it for our analysis work the way it is, because that is the real data. But because we're trying to go a bit further to predict, and that is why I'm talking about the feature engineering techniques that we will walk through, in this call. And I'm paying attention to that earlier enough. All right, so I also check in the submission file, and the submission file unique ID is combining unique ID and the country to give the value. Look at this, you see, it's combining the unique ID and the country together. Now, all we've been trying to do is to understand our data. So we can see that we have 13 columns, and the number of them are objects, a few number of them are, numeric. Now we explore, of course, you can go to those links to read more about how to explore. This is what we call the variable definition file. This variable definition file pretty much is trying to explain every feature and what they mean. So you might have that, or you might want to do that research yourself. It depends. It really depends. All right. You might have that, or you decide to do that feature, or you decide to make your research about them yourself. So country means country interview is in. Interview is in. Year survey was done. These are just information to guide you. So data preparation for machine learning, you must know that building training set is 3%. Cleaning and organizing data is about 60%, and that is where the core of the work is. Collecting data was about 19%. Mining data for patterns is 9%. Redefining your algorithm is 4%. And the other things you might decide to do is about 5%. Now, the first step is to separate the independent variables and our targets from the trained data. Then transform the target values from the object data type into numeric by using your label encoder. Now, I used label encoder at this point to be able to convert my categorical feature, all right, to numeric. I told you your computer cannot take in all these letters that we are seeing. Computer needs to process all of these letters that we are seeing. I'm trying to go to where I did my edge.edge. All right. Can you see all this data? It can't take in this data. It has to encode them to now start seeing secondary education as 0, non-formal education maybe as 1, that kind of picture is what we need to see. Please, when do we use label encoder and one autoencoder? Yes, we use them primarily. They are all encoding techniques, and we use them primarily to convert our numeric features to categorical features to numeric features. Now, when do we use them specifically? For me, the way I tell people is you have to experiment both of them and see their performance on your model. Every of these things, they are called techniques. You have to experiment them. There is no time we can say which one is the best. You have to experiment it. I tried out label encoding on my model or my data. This was the result it gave me. I tried out one auth encoding on my data. This is what it gave me. Do you get what I'm saying now? So there is no time really that you can say this is the best time to use this until when you try it and you see the result, you will see the one that is better for that data. So everything I do on any data and on any model is just based on what the data appreciated. All right. It's just based on what the data result gave me. So anything you are doing, any preprocessing that you are doing on your data, is important to say that when you can appreciate that effort is when your model performs better. So any approach you are using, that is why for one process, there are many approaches you can use. So any approach that performs well on your model is the one you will embrace based on that data. That I've used a particular approach. If I use label encoding, for example, all right, because I've used a particular pattern for my data, all right, and it worked well, does not mean that I will need to be using that same pattern again and again for every data. No, I will try and experiment as many as possible approaches to see the one that performs much better on my data. So on this task, I use label encoding. All right. Of course, you can use one or DOM too, depending on what you are doing and what you decide to experiment. And at the end of the day, which of them performs much better? That is what is most important. As far as my model is performing well, so I can say that this technique works better for me. All right. So that's what I did at this point. So what I did here was I tried my label encoder on my train data. Same thing here. I decided to now create like a function called preprocessing data, where I pass in all my numeric feature and I converted them to floats. All right. Also, look at this now. I use my get done, which is one hot encoding. I use label encoding. I use label encoding on my target bank account, while I use one hot encoding on my other categorical features: relationship with head, marital status, education level, job type, and country. All right. And that's what I did here. So after I've encoded them into the data, then I use fit model on each of them. And also another thing I did inside this my function is that I dropped my unique ID because it was not necessary. All right. And of course, I don't need my unique ID for anything. I just needed that at that point to work on it. Okay, somebody else is asking, what is the difference between minimum, maximum, scalar, and standard scalar? Just like what I've mentioned, all right, they are all scalars. We use the standard scalar most time. We use the standard scalar for numeric, all right, for numeric features. We use the standard scalar for numeric feature, and we use the minimum, maximum scalar for almost same thing, all right. But at times, we want to see the one that performs much better. They are both scalars. And all of these are just processing thing that shows the effect at the end on your model. So when you want, so the difference between them is just going to be the result that I get, all right? The result I am getting, what is the difference between them? That is the point you can really say there is a difference, or when should I use this one and use this one? They are both scalars that we use to be able to get a range of value in my numeric features. So because that in my numeric features, I will have different kinds of values, but I want to have a range of value to be stored, in my numeric features. Yeah. So I use that scalar to be able to, maximize the kind of values that are stored there within a particular range. Okay, I don't want the value to be out of 0 and 1 point something, will be 0.1, 1.2. So it won't go out of that range. So we use them pretty much as a way of also preprocessing our numeric features. Once I convert, yes, somebody was mentioning you need the math, and of course you must know that there is the math behind some of these things that we are saying. But we are saying now in relative to we are preparing for a competition. There's an hackathon before all that. These are the possible approaches we can follow. But of course, machine learning techniques, all that want to experiment as mathematics background, and that is very clear. Thank you, Olibenga, for that. So that's what I did at this point. So at this point, I decided, because I didn't need that, it was just necessary for saving data. Why didn't we encode all string features, but only some selected features? Yes, I think that's where the light of, I felt that those are the features that are most important for me, in this task. Right? That was what I did at this point. I just used the features I feel that were important for what I needed. So at this point, that was all I did here. All right. So what I did here is I also created a processed string, and I am passing that feature. I'm passing that function called preprocessing data, and I pass my S string. Yeah. Is there any techniques to choosing the best features? Yes, there are a number of them. One of them will be that you check their correlation. One of them is that you're going to use a feature selection module that helps you to look at how your model actually performed with all of the features. So that's where you try to learn out what we call feature importance. There is a library for that. So once you build your model and you pass in that feature importance, it selects the features that perform so much better on the model that you build. All right. There are a number of techniques for doing that. So I just mentioned a number of them now that you can try out, afterwards. So process on that train is what I process my S train data into. So that means all of this happen to my S train data. All of these here, you have features like this. It picks them, the one that are numeric there, you convert them to a float. The ones that are categorical, it does one auth encoding on them and does the conversion. It drops the unique ID column. Also, it uses a scalar called minimax, all right, on each of these features. That is what is stored in my process train. And it's also important to say that any preprocessing that I do on my test train data should be done on my test data too. Any preprocessing that I do on my train data should be done on my test data too. It's also very important. It should be done on my test data too. And that's why I see that I'm passing process _ test preprocessing is because whatever you have done on your test is important that you do it on your train. I mean, that's the way the logic works. Because everything, whatever you have transferred your data into in your train, you should ensure you do that to it. The only thing that is different for the two data is the part that it doesn't have a target. So most times you are advised to try every processing that you do on your train, on your test. Because if you do not do it, your test data is going to end up throwing an error at the end of the day. For example, if you have dropped something in your train and you did not drop in your test, it tells you errors like, say, 15 feature is expected, but I found 14. All right. That is, so you get some true errors if you do not ensure that you do the same thing. So most time, clean your data the same way. In fact, most time people try to merge them together and do the processing at a go and split them back, at the point that you want to build the model. So that is why that is important. All right. So of course, like I mentioned, so you can also look at this. Somebody who asks how to make selection. So 5 feature selection algorithm that you can work with. Introduction to feature selection method and examples. Feature selection techniques in machine learning with Python. So you can try that out. So at this point, all that was done here is that I decided to split my data into my X train, X value, Y train, Y value. All right. So I process the process data is what I'm passing and my Y train. All right. So I'm testing my data with 10% while I'm training with 90%. So that's what this looks like. The random state is 42. That implies that whatever it has split my data to at this point, all right, should be managed. Whatever it has split my data to at this point should be managed. So that whenever I run the code again, so it's also trying to, so the Stratify is also trying to talk about the way that my data should be splitted in my Y train. All right. So there are a number of models that, like I mentioned when I was presenting the other time, that we can use. We have the k-nearest neighbor, the logistic regression, the random forest. Then I've tried to use XGBoost. Why? Is because I've seen, I've been working with this. I've seen that XGBoost perform much better. But of course, you can try out k-nearest neighbor, you can try out logistic regression, you can try a random forest to also see it before you also come and conclude that they did not do well. All right. So you have to also try them out. It's the same way. All you need to do is import that model. All right. What is the name for the model? Import it. Random forest classifier. Import that. Then, fit is when we build our model. And when we are putting our model, we pass in our X train and our Y train. All right. This is what I have at the end of the day. So after my model has been built here, so I decided to predict on my X value, that is my validation data set. Then because the task asks us, and I know somebody is about to ask, is that the task expected that the evaluation to be used is mean absolute error. All right. So is the evaluation expected is the mean absolute error. Error rate at this, it shows that it's 0.110. That's about 10% and all about, and that is still fair enough. So I can even decide to see that this is still not very bad. The error is still not very huge. But of course, my job is to see how to reduce this error over and over. The next thing I did here was to do, like I mentioned at that time, I used the grid search CV. Our XGBoost model performs well on predicting class 0 and performs poorly on predicting class. So I told you that already. That is because we did not undo. Okay, somebody said, why should we use that? That was what that competition was expecting. All right. The mean squared error is what that competition expected us to use. So that's why I said that when you're using any competition, hackathon, you have to pay attention to the business problem and the evaluation matrix that they are expecting. That is what the task I expect us to use. All right. That's why I use that. So one way to increase the model performance is by applying Yeah, not really. It depends on the tax. So all you just needed to do here is the tax. So the model can also be used on it, and that is why you look at the way I used it. All I needed to do was to do a one minus whatever the accuracy score was. That was that's the best way to use it. All right. So the task can be anything, and I mean the competition owner also determines how they want you to use a matrix. So it's not really only on regression that you can use it. We can also use it here too, because that was what even the competition expected. All right. Okay, so another thing I did here was to use grid search CV. What am I trying to do here is that I'm trying to look at the model I built here. I actually did not use any. Look at the.
Okay, hello. So I'm sure we're enjoying the section. I'm sure probably is the internet issue from Israel's end. Okay, and I'm sure he's going to join us soon. But as he attempts to join back, so I would like to share this information with every one of us. Okay, and that is on the on how we are going to register for this for the Umujo hack, especially for the support that we plan giving and that we have started even through this training. Okay, and then for us to properly track the DSN committee member on the leaderboard, I've shared earlier that we are going to be, you have to add DSN as a suffix to our name. Okay, for example, Usman Oladako. So Usman Oladako underscore DSN. So that should be our username. Okay, so another is that we are going to continue this series. Okay, don't forget that we started on Monday, and we are going to continue this series on Monday. That's next week, Monday, which is on the okay, next week, Monday. Okay, and where Nuruddin Nasiruddin will be taking host. Okay, and also there's going to be another panel session where we can ask all our questions, where the facilitator or past Muja winners. Also, Israel, you can share your screen. You can share your screen. Okay, where past Muja hack winners can will be there, and also the country ambassador for Zindi will also be available to answer our question, and then we'll be answering question based as an insider in Zindi. Okay, so thank you very much. Okay, so let me quickly Israel. Okay, so David, can you possibly grant Israel the permission to share screen? Okay, thank you very much. So Israel, over to you.
All right, thank you very much. So just continue from where we stopped. So if we look at this, so at the end, when I used some of these parameters, so I moved from 0.1, look at this from 10. So previous one, it moves down, right? So that means the error was like coming down, and that's like a plus for me from 0.110 to 0.108. So the error came down at this point. So I saved this and submitted, to the competition. So because another time is fast pen, let me now go through another approach that I used, and the score was a bit also reduced. But of course, you can walk through this, at your leisure to see some of the things that was done in this task. All right, so same thing, I followed another process. So I didn't bother to do any, any visualization again, since I've done that already. So all I did was to do some feature engineering. At this point, I was just trying to replace some feature and change what it looks like. Then I did my, 1 minute coding on all of them now. Because like somebody asked at that time, now I'm doing on all of them now. Same thing, I use my label encoding. Here, I use my standard scalar on all my features at this point. Also, I use my smooth for balancing. Of course, there are a number of other ways of balancing your, your data, your imbalance class. So I use smooth here. There are a number of other ones. You can always check online and practice them and try them out. All right. This is just like one of them. There are many other options of, techniques you can use to undo imbalance class. So at the end, I still use my SD, classifier. And look at this at this point. Can you see now the error has reduced towards 0.08 just because I did two things. I used standard scalar this time. I used my smooth. Then I also did some, data generation. That was all I did at this point. So I don't want to take your time more than this, but you have this, the material to yourself. Yeah, I also try using, some other models, but they really did not do well. Can you see this is much? Can you see this 0.3? No, that's not where I'm going. I want something with more. Can you see this 0.2? I just tried this method to show you that you want to try as many, approaches as possible in whatever it is that you are doing. So this is my last, result. What else can we do? We'll continue to try model, we'll continue to do hyperparameter tuning, continue to try cross validation like your group fold, your straight feed. These are just a number of actions that you can perform at the end of the day. So I like the question and also say thank you to Data Science Network for inviting me for this call. So but please try this out. I'm reachable on my LinkedIn. You can reach out if you have any question, any follow up to this task. So thank you everyone for having me.
Okay, so thank you very much, Oladejo. Odejo, so sorry, pardon, for volunteering your time for this. Okay, and then thank you very much for your passion. And then I'm sure everyone has been enjoying and been following this section. Okay, so before we just conclude, I want to pass this information to every one of us that this is a series, and we are going to continue on Monday. Okay, so we are going to be sending the invite, the Zoom link to join to everyone. Okay, and then also we are going to be have another panel session as I've earlier stated. So I'm saying it so that we won't forget. And another important information that we need to keep at the back of our mind is a panel session. It's a very important panel session that I would like each and every one of us to be in attendance. Okay, so let me just share my screen so that you can see this, and so that it can help us to capture what I'm saying, especially in regards to how our name needs to look like on the leaderboard. Okay, so as I attempt to do that, let me just say it again using the name on the screen. Okay, so if Israel Odejo is registering, so he's expected as a Cindy community member to add _DSN as a suffix to his name. So we're going to be having something like Israel Odejo _DSN. Okay, so we also expect each community to form a team and register. So we're expecting all our community, especially the campus communities, to get represented on the leaderboard. Okay, so they form a team and they dedicate that team to the community. Also, the Telegram group, so do make sure you join the Telegram group for updates. The recordings and other resources for this class and for the previous classes. The previous class will be shared with us via an email and also will be dropped on our Telegram group. So thank you very much. In the access of question, to show our appreciation to to the facilitator, please kindly drop an emoji to appreciate Israel Odeajo, as we expect Nasruddin Rahim next week Monday to continue the section. Please, I'm here to see any of your favorite emoji. Please drop your favorite emoji on the chat to appreciate Israel for this wonderful, wonderful job. So thank you everyone for joining this call, and let's keep learning. And then the leaderboard, don't be discouraged. We all get there. Okay. So okay. So take care of yourself. Bye bye. Enjoy the rest of your day.